All right, so we are going to be starting 9-5, which is scientific notation. And so with scientific notation, you are going to, basically it's math shorthand, because when you start getting into, and I'm going to skip ahead for just a second. When you get into a number like this, okay, with all those zeros, there's a way, and numbers obviously can get even bigger than this, but this is just kind of a math shorthand to write this number in a more concise way without just 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. A couple things. Let's see. A couple of things I want to address here. This is considered standard form, and this is considered scientific notation. So if you're asked to write a problem in science or in standard form, then you're going to be starting from scientific notation, and you're going to be busting out to what's called standard form. Okay. And then if you're asked to write a number that we're used to seeing, which is just standard form, if you're asked to write it in scientific notation, then it's going to be some number times 10 to some power. And that's always going to be the framework. So at the top of your notes for scientific notation, I want you to write kind of just the basic generic equation, which is A times 10 to some power. Okay. A times 10 to some power. And the rule, okay, this is a big rule, and this will determine how many times you move the decimal point and what your exponent, and this n, right? This is just an exponent. We're used to seeing that up there already. The n just stands in place for whatever our exponent's going to be. But the main rule that you have to know is about A. Okay, and this is what's going to make you get the right answer or the wrong answer. A has to be, and let me make sure I word this right. And we'll talk through what it means here in just a minute. A has to be greater or equal to 1. Okay, and A has to be less than 10. And A can be a decimal. Okay, it's going to be a decimal most of the time. So your A value, and if you look here, right, this 9.0, that's the A, right, times a 10. And in this case, the N is a 3. Okay, so when we're looking at scientific notation, on the ones that are already in scientific notation, notice something about every single one of these numbers, okay? They're between 1 and 10. 2.4, it's between 1 and 10. 9.0, 4.385. It doesn't matter how many decimals you go out, as long as the decimal is right here, it's 4 point something, it's between 4 and 5. So it's between that 1 and 10, okay? It can be a 1, but it can't be a 10. So notice it says or equal to 1, but less than 10. Because if it's an actual 10, we would move the decimal place over one more and make it a 1. All right. So you're never going to have a 10. You're going to have anything between starting at 1 and up to 10, but just shy of 10. So 9.9999999 forever and ever would be the biggest A you could have. Okay. And like I said, you don't have to write all these down. I'm just pointing out when in scientific notation, 1.03, 5.11, 1.0. Notice 1.0 is fair game. 8.49, 8.75. Even this one, no matter how big the number looks, the decimal point is right here. So it's 6 point something. So it's between 6 and 7. Okay. So if you'll notice every one of these in scientific notation, the A is always 1 up to not quite to 10. Okay, less than 10. All right, so let me delete all of these and talk about how we write these in expanded form. What does that exponent mean? Well, the exponent means if you take something times 10, if we just don't think about the exponent of 4 right now. So if we just take this and make it even more basic, if we go ahead and write this one down as your first example. 2.4 times 10. What have we learned without putting this in a calculator? What have we learned about multiplying something times 10? Yeah, you move the decimal 1 jump to the right. And so this makes that equal 24. It's not there, but it's there. What is the exponent of that 10? It's a 1. So the exponent tells you how many times to jump your decimal. What? I got a confused look. Huh? No, we're not doing this problem yet. I did a more basic problem first. I said to rewrite, I said, we're going to do a basic one first. We're not doing this one first. We're doing this one right here. Sorry, I'll make it to where it's the only one on the screen. Sorry, no wonder we had confused looks. So this was the problem I wrote. I said, if you had 2.4 times 10, just very basic math, multiplying something times 10 means you move the decimal one spot over to the right. And the reason it's one spot over to the right, it's not there, but it's there. The exponent is a 1. So the exponent tells you how many places you're going to move that decimal to the right. Okay. And the reason we move it to the right is because 10 to the 4th power is a really big number. So we want to make our base or our a really big number. Okay. It's a very easy way to remember which way you're moving your decimal. 10 to the 4th power is a big number. We want to make our a really big number. So on this example now we'll go to the first one that was actually on the paper, which is 2.4 times 10 to the 4th. Okay, we're going to take 2.4. Well, let's do that in black. Sorry. We're going to take 2.4 and we are going to start where our decimal point is. We're going to put our pencil right there and we're going to go 1, 2, 3, 4. And that's our new decimal point. Now we just can't have that 2 and that 4 floating, right, out in the air. We have to add the zeros required to make this a full number. So it is 2, 4, 0, 0, 0. And the last step, does anybody know what I want you to do? Put a comma where they go. 3 spots over from the start or 3 spots over from the right. Every 3 decimal or every 3 places gets a comma, depending on how big your number is. So if you do not have a comma in your final answer, it's going to be points off, okay? You have to put a comma in your final answer. So what I don't want you to do on your papers, okay, and this is laziness, I don't want you to go, notice how I wrote 2.4 underneath the problem. I moved my decimals and then I wrote my final answer in a nice, neat way with the comma where it goes. What I don't want you to do, and I will not, I'll just mark it incomplete. I'm telling you all this now. I don't want any surprise faces. If you turn in your homework or when I'm walking the room checking your homework and you've taken your pencil and you've gone 1, 2, 3, 4, 5, 6, 7, and you put it there and you put a bunch of zeros there and I'm not accepting that. That's incomplete work. Okay. I'm being very clear here about what I'm expecting. Noah?
What if we just write, instead of moving the decimal, we just write 24,000?
I want to see the work. Okay, you always have to show me the work in math, because if it's wrong and you just have a number there, I'm not going to be able to help you to see what you did wrong. So for every one of these, I want you to write the number underneath, just like it's written. Then I want you to take your pencil. I want you to place it where the decimal was. You're going to move it 1, 2, 3, 4, 5, 6, 7. You're going to put the new decimal point. You're going to fill this in with zeros. And then out to the side, you are going to write your final answer, which is 4, 3, 8, 5, and then 4 zeros. And then you're going to come back and you're going to put a comma every 3rd spot. And that is what you're going to circle for your answer. I want everybody to, I'm going to leave this here to make sure everybody has this example, just like I've written it in your notes, because I don't want any surprise faces tomorrow when you don't have these steps and I count your paper as incomplete. Riley?
So all we're doing is pulling the A
Down.
and then we're writing it out as we're moving the decimals.
Yep.
And then we put it equals,
Mhm.
and then
Put your commas in the right spot. Yep.
that's it.
That's it for this part of it. I mean, we're going to go the other way here in a second. Lakin?
You said put a comma for every 3rd zero, but you put a comma after 43.
Every 3rd, I didn't say every 3rd zero. I said every 3rd place.
Yeah, but there's 2 numbers and you put a comma, and then there's
From this direction. When you write the word, when you write the number 1,000, where do you put the decimal or where do you put the comma? Yeah, it does. It has a comment. Starting from the back side or starting from the right, every 3rd spot gets a comma. No matter how big the number is, every third spot gets a comma. That's just,
So there has to be 3 spots in between.
yes. And so notice 43, there's not a comma on the left of that because that's the beginning of the, so you put your commas in from the, kind of looking at it, reading it backwards. You put your commas every third one from the right, reading backwards. Okay. All right. I don't think I need to labor this. I am going to do one like this just to show you. Okay. I'm going to rewrite my A. 1, 2, 3, 4. Now I'm going to put my pencil where the original decimal was, and I'm going to go to the right. 1, 2, 3, 4, 5, 6. Okay. Notice I don't have to add any zeros here because the decimal only had 6 spaces to move. So 6, 0, 0, 0, 0, 3, 2. And then starting from the right, work your way backwards and put a comma every third spot. And that's what you're going to circle as your answer. Okay. I don't think those are all the ones with positive. All right. Now I want to show you what you do when it's a negative exponent. So write this example down, 8.49 times 10 to the negative 2. And you don't have to write this, but I hope you all have understood this now to this point. To deal with that negative exponent, how would I rewrite 10 to the negative 2? Lakin?
You put 1 above.
1 over 10 to the second power, which is 1 over 100, which is 1/100th. It's a teeny tiny number. Think about if I were to bring just a pie in here and I were to say, let's cut this in 100 slices. Can you imagine how itty bitty each slice would be, right? It's a fraction. So a negative exponent makes you have a teeny tiny number because negative exponents are teeny tiny fractions. So if you need to write yourself that as a reminder, okay, negative exponents equal tiny numbers. And what do I mean by tiny numbers? Tiny numbers are numbers where the decimal is here and then you've got a bunch of spaces here because that's a fraction. There is, I don't want to say no whole number, but the number gets much smaller, okay? So as before, we were making massive numbers like, whoops, 6 million, right? Because we were taking them to positive exponents. So we were blowing these numbers up huge. When you have a negative exponent, you're doing the opposite. You're shrinking these numbers down teeny tiny. So because of that, let's go back to here. You do it the same way. 8.49, I rewrite my A. I put my pencil where the original decimal was. And now because it's a negative exponent, I'm going to go backwards 2 jumps and put my new decimal. Again, I can't leave an empty space. So I put a 0 in the spot. And now for my final answer, I rewrite 0.0849. And that's my answer. Okay. No commas needed on fractions. So if you need to make yourself a note of that, no commas needed on decimals. Commas only go in the big whole numbers. Yes.
Do you want us to put a 0 on the decimal?
That was my next thing. I don't care. I'm good either way. A lot of times the book will put 0.0849. I'm good with either one of those. Okay. It does not matter to me. There's it's kind of like, I always say, what's the number in front of that X? What is it? It's a 1. It's there, but it's not there. What's the exponent of the X? 1. It's there, but it's not there. That 0 at the beginning before the decimal is kind of like the understood ones and things in math. Okay. Some teachers require you to write it. I don't know it's there. If you ever see it on a multiple choice question and it's 0.0849, the 0 is just kind of it's always there. Okay. Good question. All right. So let me see if there's anything that jumps out at me that would be on your homework different. I don't believe so, but I just want to always make sure I cover something in case you see it on your homework. Do one more then. We'll do 4.93. So step 1 is I'm going to write 4.39. I'm going to write my A right like it was. I'm going to put my pencil where the original decimal was, and I'm going to go backwards. 1, 2, 3, 4, 5, 6, 7. I'm going to put my new decimal point. Now, if you're sloppy and you miss zeros because you're sloppy, then that's on you. Go slow. Give yourself nice open swishes so that you know everywhere where you need to place a 0. Okay. And then you're going to write your correct answer as point and then count your zeros. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And then 4, 3, whoops, don't want that gap there. 4, 3, 9. Okay, so the decimal is no longer here. And if you want to check that you did it right, you can always really lightly with your pencil check to see what if you go back the other way 7. What if you go 1, 2, 3, 4, 5, 6, 7? Does that get you back to your original one? If it does, you've added the right number of zeros. Now you don't have to do that. Okay, I'm just showing you that if you're sloppy, and I'm just warning you now. Okay, if you're a sloppy person and you do this and you start adding zeros in there and you have no idea how many zeros you're adding because you are sloppy, that's on you. Okay, go slow, give yourself a nice good count and a nice well or a nice spot for each 0 that you know you need to add. Okay. All right, now going the opposite way. Notice the directions here. On these directions, it wanted us to write the equation or write the number in standard form. Standard form is how we're used to seeing it. Now we switch to express each number in scientific notation. So every single one of these, okay, make yourself a note of this again. Every single answer is going to be A times 10 to some exponent. Scientific notation is A times 10 to some number, and I've got to move my decimal points enough that my A, remember, is between 1 and 10. It can be 1, it can't be 10. Okay. And then depending on which way you're going is whether or not you're going to have a positive or a negative exponent. So if we have a really big number and we want to make it really small, okay, we put our decimal where it's at, which if it's a whole number, the decimal is always at the end. And we bounce as many times as we need to put our decimal in the spot where we need it for our A to be proper. So in this case, that's 1, 2, 3, 4. Okay. For these, you don't have to rewrite the number. So I moved my decimal 10 spaces. So my new A is 4. Is 4 between 1 and 10? Am I good? Okay, so my new A is 4 times 10. Now to the what power? How many moves did I make? Cam? 4. And since this was a really big number and I made it a really small number, I need my exponent to be positive, because if I were to re-expand this, I would want all those zeros added back on, right? How about this one? This one right here. 876, comma, 000, comma, 000. That's in standard form. I want to put this in scientific notation. Put my decimal at the end, because that's where it goes on every whole number. And I bounce 1, 2, 3, 4, 5, 6, 7. Can I stop here? Why not? Because 87 is too big of an A. I got to go one more bounce to put my decimal. Now 8.76. Am I between 1 and 10? Is my A good? If my A is good, I write my A 8.76 times 10 to the, and then if you lost count or you don't remember, go back and check. 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th power. So I took a giant number and I wrote it in scientific notation. And if I re-expanded it and added all those zeros back in, I'd have a giant number again. Gage? Okay. Not yet. And we're going to go to the negative one next. All right. So here is a teeny tiny number. If you see a teeny tiny number, right? I know it's a teeny tiny number because the decimal is right here. And that means it's 0.000037, which would be like 37 over 10,000. It's a tiny, teeny fraction. Those are the ones that are going to give you negatives. Okay. So I bounce again, but this time I'm bouncing the other way. I'm going 1, 2, 3. Can I stop here? Okay. 4. Can I stop here? 3.7. Is that a good A? Okay. I stop here. 3.7 is my good A times 10 to the. Well, now if you think about, if you cover up the black problem that was your original, and I just gave you 3.7 to the 10 to the some power. If I told you I wanted to make it at a teeny tiny decimal, would you tell me a positive exponent or a negative? A negative, because teeny tiny numbers get negative exponents. So this would be to the negative 1, 2, 3, 4. So when you make big numbers little, okay, here, I'm going this way, 1, 2, 3, 4. Can I stop here? 91.9, is that a good A? Got to go one more, 9.19, is that a good A? 9.191, make sure you include all the real numbers, times 10 to the, how many bounces did I make? 1, 2, 3, 4, 5. And if you're not sure if it should be negative or positive, cover up the original problem, right? Cover this up. Look at what the answer that you wrote and ask yourself, if I work that out, am I going to expand that into a really big number, or is it going to be a teeny tiny number? And the answer is it's going to be a big number. I'll do one more. We're going to do this one and then we're going to be done. Okay. 0.6 or 0.0067. Take a minute. I want you to try to work it first. Get it in your notes. Try to work it, and then we're going to work it together. Shouldn't say we're done with notes. We're done with the new stuff, and then we're going to use it and apply it in a way here. All right. So I put my pencil where there was a decimal. I bounce 1, 2, 3. Ask yourself, is 6.7 a good A? It is. It's a teeny tiny number. So I'm going to have a negative exponent, and I bounced 1, 2, 3. To check your work, you can reapply the negative exponent, make it a teeny tiny number, and it would match. Okay. Now this part is what you're going to have to do in your homework. Okay. Order each set of numbers from least to greatest. Least to greatest. Okay. So to do that, you're going to have to move some decimals. You're going to have to take 7.35 and you're going to have to move it 1, 2, 3, 4. Okay. Then you're going to have to take, that's this one. Then you're going to have to take this one and move 1.7. I'll move that over. It's going to go the other way. 1.7. And I'm going to go backwards. 1, 2, 3, 4, 5, 6. Lots of zeros in there. Then I'm going to take the next one. 8.26, and I'm going to bounce 1, 2, 3. And then I'm going to take the last one, 9.3, and I'm going to bounce backwards twice because it's a negative. Now you're going to have to decide, order each of these numbers from great to least. Now, I am actually fine with this because I always, if I can help for you, hit the easy button. I want to. If you want to write the numbers above each one of these so you don't have to rewrite them out to the side, I'm fine with that. So let's figure out, it says from least to great. So what is the smallest number I have here? Somebody tell me just the color. What is it? Blue. Because it's this teeny tiny number with a 1, 2, 3, 4, 5. It's like to the millionth or something. So this is my least number. So I'm going to make that number 1. Next, what is my next least number? Tell me a color. Green. So that I'm going to number 2 because that is second in line. Notice I'm going least to greatest, not greatest to least. It'll matter. So watch your instructions. All right. What's my next greatest number? My next, I'm going from smallest to biggest. Red was 73,500. Purple is 88,260. So which one is going to be next up in the smaller to bigger? But did we move 4? From here, we moved 1, 2, 3, 4. So we had to add 2 zeros, which makes it 73,500. You see it? Purple's the next one because it's 8,000 something. And then 73,000 something is going to be the next one. As long as you show me, and I'm being very clear here, as long as you show me all of this work on this lane right here, this lower level, you show me the work of making them all into standard numbers, I'm fine if you number them least to greatest on the top, and I won't make you rewrite them out to the side, least to greatest. Are we good with that? All right. Let me check your homework and make sure. Yep, that is everything on your homework. The other thing you're going to have to do is you've got a mix here. This is in standard. This is in scientific. What are you going to do with the scientific? Put it in what? Standard. This one's in scientific. Put it in standard. This one's already in standard. You don't have to do anything to it. Then you can compare them all. They all have to be in standard before you can compare them biggest to smallest. Okay? Sound good? And you can't just rely on the exponent because it depends on where the decimal's at. So you have to put these in standard form before you can put them greatest or least to greatest. Okay? All right. Your homework is odds only. And we've already done so much bonus this week that I'm not going to do any bonus on this one. But I've got enough bonus out there right now that everybody should have like an A+++++. If you haven't taken a test, well, I haven't graded all the tests. I think I haven't mentioned it. So I've got a lot of bonus sitting right there. I'll come around the back and get extras. I know there are some, so I quit counting about halfway through. Odds only, read the directions of each section so you know what you are doing. They changed, there's 4 sections, so there are 4 separate directions. If you don't read the directions, nice, that was a guess. Extras? Oh, there, you got it? Okay. Extras, extra? All right, you guys have got about 5 minutes. You can probably knock through a good bit of these. All right, for those of you at home, it's odds only. Email me if you have any questions and submit through Cami when you're done.